In this video, we are going to look at sets, and in particular, we're going to be describing the shaded region. So here I have my first diagram. I have my universal set, see the U here. This rectangle is the universal set. And all I have within that universal set is the set A. So the shaded circle would be set A. So to describe this shaded region, it will just be set A. So all I have to write is A, meaning the shaded region is just set A. Now if we come down here to where we have two disjoint sets, so our universal set again is the rectangle. We have set A and set B being disjoint sets. But notice only set A is shaded. Set B is not shaded. Therefore, to describe the shaded region here, it would just be set A. So all we have to write is A, meaning that this shaded region is just set A. Now coming across here, we have subsets. We can see that A is a subset of B. Again, our rectangle is the universal set. And again, only set A is shaded. Therefore, to describe the shaded region here would just be set A. So all I have to write for the answer would be A. So now for this diagram down here, we have intersecting sets. So set A is intersecting set B. But again, only set A is shaded. And therefore, to describe the shaded region here would just be set A. So again, the answer will just be set A. Now moving on to this diagram here, we are seeing that we only have set A within our universal set, but everything except set A is shaded. So notice A is not shaded, but outside of A is shaded. And that's what we call the complement. So all the elements that's not in set A would be A complement. So the shaded region would be A complement, meaning not A. And the way we write that would be A with this little stroke on the top of it like that. And this would mean A complement, meaning not A. So everything except A is shaded, which is not A, which is A complement. Now if we come down here, we have our disjoint sets. A and B are disjoint sets. And notice again, A is unshaded, but everything else, set B and outside of set B and A, is also shaded. Therefore, again, this would be the shaded region would be A complement, meaning everything except A is shaded, which is not A. So the shaded part is not A. So we write that as A complement. Now coming across here, we have our subsets where A is a subset of B because the set A is inside of B. But notice, A is not shaded, but everything outside of A is shaded. And again, the shaded region would be not A, which is A complement. So again, the answer here is A complement, not A. And for the last diagram on this page, we have our intersecting sets, A intersecting B. But again, A is not shaded, but everything outside of A is shaded. Therefore, the shaded region would be not A, which is A complement. Now moving on to this diagram here, we can see that we have our universal set, and both set A and set B are disjoint sets, and set A and set B is shaded. Now we know all the elements in A together with all the elements in B would be the union of the two sets. And since both A and B is shaded, then the shaded region would best be the union of A and B. And we write that as A union B. Now coming across here, we can see the opposite. We still have disjoint sets, and we have set A and set B unshaded. And everything outside of set A and also set B is shaded. Therefore, if this is the union of A and B, and everything except the union is shaded, then the shaded region would not be the union. And we write that as A union B in brackets complement, because you can clearly see the union is shaded here. And in this diagram, the union is not shaded, but everything except the union is shaded. So the shaded region is not the union, and that's what we call A union B complement. Now moving on to our intersecting circles. So we have A intersect B, and we just shaded this part here, which is the intersection of A and B, which is the part that set A has in common with set B. That is this part here. And this is what we call the intersection. So only the intersection, which is what set A and set B have in common with each other, or the elements they share with each other. So the shaded region here would be A intersect B. Now notice here, we have intersecting sets again. We have set A intersecting set B. But everything is shaded except the intersection. The intersection is not shaded. And since the intersection is not shaded, and everything except the intersection is shaded, we could say the shaded region is not the intersection. And anytime we say not, we're talking about complement. So the shaded region will be A intersect B, and since it's not the intersection, we put a complement there. So this means everything else is shaded except the intersection. That's what this means. So intersection shaded, A intersect B. Intersection not shaded, but everything except the intersection is shaded. So A intersect B in brackets complement. Now let's look at this diagram here to describe the shaded region. Now we can say we have intersecting sets. Set A intersects set B, but both the whole of set A and the whole of set B is shaded, and therefore this again would be the union of these two sets. Although they are intersecting, all of set A and all of set B is shaded. Therefore the shaded region would be A union B. And likewise across here we can see all of set A and also all of set B is unshaded. So although they are intersecting, all of set A and all of set B is not shaded. So that means everything except the union of set A and set B is shaded, which would be A union B in brackets complement. Now let's look at these two diagrams. Obviously set A and set B are intersecting each other, but in this diagram only set A is shaded, so the shaded region would be set A. And in this diagram everything except set B is shaded. So set B, the whole of set B is unshaded, and therefore the shaded region here would be not B. So we're going to put B complement, not B. Now remember, the intersection of two sets is the region that both sets have in common. Now if you look at these two diagrams, we can see set A is shaded, the whole of set A is shaded. But in this diagram, the whole of set A is not shaded, everything outside and this little piece here. So if we ask what these two diagrams, the shaded part, what they have in common, this region here, this region is common to both set A and B complement. So again, you can see this is set A, the shaded region here is B complement, and what's common to these two shaded regions would be this part here. And this is what we call A only. So A only, which we could also write as the intersection between set A and B complement. So A only could be written as A intersect B complement. So likewise, this shaded region here would be B only. So we call this B only, which would be the intersection between set B and A complement. So you can write that as B intersect A complement. And that will bring us to the end of this video.